Hello and welcome back. This is a A2 A2 Edexcel past paper for June 2014. Now this paper we're doing question 4 in this little video here. Now this question is a fairly standard question. It's probably the easiest question on the paper. However, the last part C, is as hard as you make it. Now, I don't mean you can invent a question by that. It's how well you read the question in comparison to how difficult it therefore is. So anyway, the first two parts to this question, so part A and B, are translation, sort of you're trying to work out what it's saying. First of all, it gives us this graph, which is y equals the given function of x. And we're given the y-intercept of 11, so that's obviously the point 0, 11. And then we're given the x where it touches the x-axis, which is 6 minus 1. Should be going through it, that one. Yeah, sorry, that's the vertex, I've not drawn that right. Obviously, I'm assuming you've got it. The paper open. So the vertex is 6 minus 1. Okay, so just a couple of things before we go into this question about this graph. Obviously, you've got the two equations of a straight line. The first part of the part where x is less than 6 is one function of x, and then from x is larger than 6 is the modulus, or where the inverse of that graph, that line, so to speak. Well, it's not technically the inverse, but both they're sort of opposite to each other. So yeah, hopefully that makes. If it doesn't make any sense, don't worry, because it's not really required for this question. Although it does come into part C. But you don't really need to know about that little bit I just explained. So anyway, let's kick off. The first part says y equals, and the modulus sign is over the whole function of x. So not just over x in the equation of the line, it's over the whole of the function of x. So how do we define that? Well, a good way of looking at it is saying, actually realising what this is saying. It's saying that a y coordinate always equals the modulus of the whole equation. Now, we have to think back to what modulus is. This is one of the first things you do when you're talking about modulus in C3. You say when a modulus just turns it positive. So if you've got minus 3, that's plus 3. And if it's already plus 3 and you do the modulus of plus 3, it's just 3. So it just keeps the sign positive. So therefore, if every y, because the y coordinate is equal to the whole function of x, positive. So y, therefore, even if x is negative, y has to be positive because the modulus sign turns it positive. So the graph, the y coordinates where the y is, always has to be greater than 0. But x can be less than 0 if it wants to be, if it likes to be awkward. But the key thing for this to take away from this is y is always greater than 0, so it's always above the x-axis, in other words. So, because we've got a point here, that's 6 minus 1, obviously you've got a small range of the graph that is below the y-axis, that can't be below the y-axis anymore. It can have the same values, but it has to be positive. So therefore, we have a graph that looks something like this. So therefore, see, mine should continue to go on. But the key bits that I'll tell you about now. So the y-intercept hasn't changed because the modulus of 11 of 0 is always going to be 0, and the y-coordinate doesn't change. Okay, but the vertex, that's 6 minus 1. If you do the modulus of, if you input 6 and minus 1, you're going to get, because that is equal to the y-coordinate, you're going to get the positive version of 6 minus 1, which is obviously going to be 1. But it's not just 1, because that's the y-coordinate. It's the whole function of x. So therefore these coordinates are both going to be positive. Sorry, the y-coordinate is going to be 10 positive. I'm going on that. But they end up both being positive. Anyway, it's just flipped over, so it's mirrored in the x-axis. you can think of that. So therefore we get the vertex is actually being, not the vertex anymore, it's 6, 1. So that is our x coordinate 6, y coordinate 1. So that's all that's changed. We've just flipped it over. Now this other bit, this is going back to C2, C1 actually, maths, where we did translations of graphs. Now this is a little bit more extreme because we've not only got one translation or reflection or whatever, we've actually got 3 things we have to do to this graph. One of them, they only really bothered about, because they're giving you coordinates here, and they've said on the exam that showing all the coordinates of the intercepts of the axes, and obviously you would give the coordinate of Q, because it's any coordinate it gives you on the graph. When you're asked to translate it, reflect it, move it, especially stretch it, that's one of the key ones, because you can't really show stretching in terms of how curvy it is, so flat or gradient or whatnot. So you just show it with the intercepts. And so anyway, we have to work out what this is saying. Now, so y equals f of x, that's the standard graph, that's the graph that hasn't been messed with. We'll go from the left. So we've got a stretch of 2 here with respect to the y-axis. I don't need to explain, I did explain that in my C2 or 1 video, whatever it was. So, you can look back to that one if you don't understand. So, so when it's outside, it's timesing the whole function of x by 2, which means it's timesing y by 2 as well. So that's why we got a stretch of y with a scale factor of 2. All that means you times the y coordinates by 2. We've got minus x here, so that means for every x coordinate, or every x in the function of x, that is turned times by -1. So if every x coordinate is times by -1, that's a reflection in the y-axis. And then plus 3, that's just moved up 3. So, recap what we have to do. Times every y coordinate by 2. Which, this has become 0, 22. So what I do is somewhere else just make a note of what the coordinates become. But because I don't have enough, quite a lot of room, I'm going to use this section. I'm just going to draw off the original coordinates, which you could do if you want to, but, So anyway, this comes, we can't actually say what it comes yet because we haven't gone through the rest of it. So anyway, it would be times by 2, so provisionally it's going to be 0, 22, so provisionally I wouldn't write that down, even though I kind of led you to that, but never mind. It's reflected in the y-axis, which obviously because that's at 0, the line is going to be in the reflection, so it's not going to change. And then you move it up 3, so times 2 plus 3, that's what happens to the y coordinates. So we've got a y coordinate of 11 times 2, 22, plus 3, obviously 25. So the coordinate doesn't become 25, it becomes 0, 25. Now with Edexcel, they'd like you to put the proper coordinate in AQ8, you could just put 25. But Edexcel like you to be fussy. And then we're told, so that's that coordinate done. The other coordinate, so it's times the y coordinate times 2, so provisionally it's going to be 6 minus 2. And then we reflect it in the y-axis, so the x coordinates change sign, so therefore it's minus 6 minus 2, and then we move it up 3, so this end becomes minus 6, 1. Okay, so that's the end coordinate of that. So we've got 2 coordinates here, and I'll just put them on somewhere. So this becomes 0, 25. You can draw it in the same sort of space, but you need to think of, okay, right, well, that's 0, 25, so in comparison we need to make the other one a bit smaller. And then the other coordinate is minus 6, 1, so it's minus 6, but 1, we'll see it's sort of there. So then we need to look back at what the graph originally looked like. So, it's been moved up 3, and it's been reflected in the y-axis. So I'll just give you a second if you want to have a go at that. Now, it's been reflected in the y-axis, so it's reflected from right to left. So, okay, so on the left-hand side, we originally had a sort of horizontal diagonal line, and on the right-hand side, we have this sort of what could I say? Points. Could say words slip my mind. So therefore we're going to have the point on this side and the diagonal line on this side. So it's going to have something like this. Okay, so that's what it's going to look like. As you can see that, as I said, you can see that from the mark scheme. That is fairly simple, but you just need to make sure. That's why I thought it was a good idea to put the coordinates on before, so you can see where we get these points from. And I'm not just drawing it on like it has done on the mark scheme, because I'm presuming that's why you've gone to the effort of having to watch me talk you through this video. So, as I said, hopefully that's been helpful. Part C now. Okay, part C is a little bit different actually. So sack this, I'm going to rub both of them off. So, I've taught you through them, but if you want to copy them down again, the answers are on the mark scheme, as we said. So I actually went against me and point there, I leave myself some room. Didn't need to. Just to make it more awkward for you, because that's the kind of guy I am. Right, okay, so, what's the next part of this? Right, so at the top we said, given that f of x equals, so f of x equals a times the modulus of x take b, take 1. Where a and b are constants, so state the value of a and b. Now this seems quite complicated, because you think, oh, alright, okay, so from what we said before, Will, what we have to do is work out the equation of this line and do the negative one, and then work out the equation of this line. Well, you'd be wasting your time. I'm sure you could do it that way, but I'm not going to, because I don't want to bore you to death. As I'm assuming you're quite close to death from watching this video already. So, key difference. This is why I said this question is as hard as you make it. This function of x was said given that, not show that, we're given that. That's the key bit. The show that is you are meant to use some maths on what you currently know from the question to be able to put it in this kind of form. However, this question is not asking that. This is asking, given that f of x, so we're told what f of x is equal to, but just to be nasty, they started throwing bits of the alphabet in there. So we've got f of x equals a modulus of x take b minus 1. So, as we're given that, we are allowed to use that in our answer. Now this f of x, as we said, y is equal to f of x. So, as y is equal to f of x, we can rewrite this, and this is the first thing I do. Y equals the a times the modulus of x take b minus 1. So that's the first thing I do. And we've got, you will notice, obviously, we've got two coordinates here. We've got, so I'll rub that 0, 25 out because that's just confusing. So the two coordinates we've got are 0, 11 and what was it? 6 minus 1. So these are x and y coordinates. So therefore, we can rewrite these as saying when x equals 0, y equals 11. And when x equals 6, y equals minus 1. As I said, I'm not putting any new information in there. I'm just rewriting the coordinates in a form so we can kind of get somewhere with this. Because as I said, we're not asking to prove this, we're just asking to show. We're not asking to show this, we're just asking to work what a and b are out. So, okay, so when x is 0, y equals 11. That's the first one I'm going to do. So if we put it into what we're given, so we're given the y equals the a times the modulus of x take b minus 1. We know what y is, we know what x is. We're going to plug these numbers in and see what happens. So, y equals 11. This pen is a bit pants, but never mind. 11 equals a, we don't know what a is yet, times the modulus, we know what x is, 0 minus b, take 1. So we can simplify this down. This pen is really bad. I don't even use the black pen that much. Okay. So, Sorry, I'm just, yeah. Now, what we can do here is move the 1 over to that side, so that'll get it equal to 12. So 12 equals a times the modulus of negative b. And now this negative b turns obviously to positive b, but it also could be negative b, because when you do the modulus of something, it can be either the modulus of the positive number or the modulus of the negative number. So therefore, a times plus or minus b, so I'm just going to write b, equals 12. However, as we're told, a is not equal to 0. Oh, sorry, no. I just read the question wrong. Yeah, so a times plus or minus b equals 12. Okay? So that's one equation there that we've got. As I said, all we've done to get that equation is put our numbers in the formula. So we'll do the same in the equation below. So you can say we're starting to get some kind of formula here of two equations. So we got y is equal to minus 1. So right, minus 1 equals a, we don't know what a is yet, times the modulus of x take b, that's 6 minus b, take 1, and we can simplify that down. So obviously a times 6 take the modulus, a times the modulus of 6 take b. If we move the minus 1 over, we get a times the modulus of 6 minus b is equal to 0. Therefore, a must be 0, or 6 take b must be 0. So rewrite this equation underneath, because I'm trying to save myself some room. So therefore, it's 0, because we moved the 1 across, is equal to a times the modulus of 6 take b. So therefore, a must equal 0, or 6 take b must equal 0, in which case b equals 6. Okay? However, as we're told, a cannot equal 0 in this question, so we can rub that a out. So a is not equal to 0, so all we've got from this is that b must be 6. So if we go back to our other equation, what we've got here is we said a times plus or minus b is equal to 12. Now we know what b is. B is 6. So therefore, a times 6 equals 12. Plus or minus 6, equals 12. So if we rearrange this, we can say a is equal to plus or minus 2, because 12 over plus or minus 6 is plus or minus 2. So therefore, a is plus or minus 2 and b is 6. However, we want it in this form. Does it say something? We must be missing something in the question. So I'm sure I'm missing something. Oh, where have I got minus 2 from? Sorry, I don't know where I was going with that. We already just got myself confused. So anyway, because we know what b is, because in this, when we did a times plus or minus b, we didn't know what b was. But as we know, b is 6, positive 6. So therefore, a must be just 2. Sorry for getting confused there. So we've got our equation of b and a. Now what you could do is you could put back into this formula, but you won't get a b and get any more marks, because all we're asked to do is find out what a and b are. So that last part C was as hard as you make it. I made it a little bit more difficult than I probably needed to. But basically the first two were very simple in terms of you just using your functions, you were just graphing, doing translations really. But that part C required you to think a little bit more, and I think that's why it was worth the, it was only worth 2 marks. Yeah, so it was only worth 2 marks. So if it's only worth 2 marks, that's the other way of looking at this question. If you started to do your gradient of your line and work out the negative of that equation, you'd be doing quite a lot of work. And since it's only worth 2 marks, There's never been, apart from, if you're interested, January 2007 question, it was the last question on the paper, that was only worth 1 mark, but it was the most stupid question that I've ever seen. I mean, one of my teachers went to Oxford, and he had trouble doing that question. Well, he didn't have trouble, he thought it was a bit excessive for 1 mark, and that's the only ever time I've seen something where it's a relatively insignificant mark compared to the rest of the papers. The paper's out of 75. It's not really worth the 1 mark. It's worth a lot more than that. But seeing as this, that rarely happened, that happened once. So whenever a question is worth a max, generally 1 to 3 marks. If it's between 1 to 3 marks, it's not going to require an excessive amount of working out. Mainly it'll be thinking in them kind of questions. So anyway, back to this one. So if you were doing the equations of these 2 lines and it's only worth 2 marks, you must be doing something wrong, because we're only halfway through the paper. It's only worth 2 marks. So you'd be wasting your time doing that question. So that's why there's a key thing to watch out for in that question. So therefore, if you that's why you need to realise, and also we're given that, and as we're given that, we don't need to work out anything. So that's, I mean, if that doesn't give it away, then hopefully the fact that it's only worth 2 marks will be obvious that not meant to require proving that, because it's not saying prove it. So anyway, as I said, hopefully that's helped. If you want me to have another stab at explaining that, I will do, but as I said, I'll try and keep up with the times. So anyway, thanks for watching, and we'll see you in question 5.